All right. Hey everyone, welcome to another deep dive. This is a round two, actually. So this is with, you guys still have the same name? Or it's
Same name, Uma. Yeah,
nice.
yeah. Round round
Yeah,
two, and we'll do round three soon enough, I hope. So yeah.
completely. And this is Hart. So Hart was on with me last year. It was a great episode. You guys can go watch that. It was a little over a year ago now, on their optimistic design. So just I guess to kind of kick things off, like we'll assume sort of a general knowledge of what UMA is, but like what has happened for you guys over the past year, and like maybe even just like lay out the landscape, like what's the space look like over the past year?
So I think the most interesting direction to kind of take this conversation, Nick, is to talk about optimistic designs generally, and then
Sure.
like what optimistic designs for sort of oracles look like. Um, and as a specific example, Uniswap X was announced a month and a half ago now. And they talk about a cross-chain system that uses an optimistic design for their kind of cross-chain settlement. Um, and I've been seeing like more and more of this in the space too, where people are taking this optimistic concept, kind of call it like lazy computation or only validating things if you absolutely need to. That's being used a lot more than it has been in the past year. And yeah, I think that's kind of like a cool concrete angle to kind of steer the conversation around. And I
Yeah.
guess to, yeah, go ahead. Sorry.
No, I think that would be so. For those that don't know, like what is Uniswap X and what was that announcement?
Totally, totally. So Uniswap X is Uniswap building an RFQ system that basically sets orders that are Dutch auctions, which we can go into, but set orders to allow off-chain actors, which they call fillers, I'll call them market makers, to fill a cross-chain swap at a price better than Uniswap on-chain liquidity could provide. Um, so interesting idea, heavily inspired by CowSwap and like 1inch Fusion, which are other kind of RFQ like systems out there. But basically, the way, the complementary way I'd frame this, and some people have pretty harsh takes on it, but the complementary way I'd say this is you have on-chain liquidity in Uniswap and like AMMs, and we're going to run an RFQ system that does price improvement over that on-chain liquidity. And if there's somebody willing to pay a better price, like a market maker, they can go and fill the user order at a price better than they could get on chain. Um, that doesn't matter for what I'm talking about, the optimistic stuff. What was interesting, what's interesting is the cross-chain design. So they're like, okay, well, can we use this RFQ system to do cross-chain swaps? And like you can do the RFQ thing and say, okay, like, yes, a market maker will fill me on chain Y if I send them assets on chain X. But then there's just kind of it's almost like a settlement system concept where how do I validate that before I give the market maker my assets on chain, on the origin chain, how do I validate that the market maker got my assets on the destination chain? Um, and I don't want to release funds until I've proven that happens. Um, and this, like cross-chain messaging broadly, can be framed as an Oracle problem. How does one chain know what's happening on the outside world, this other chain? And Uniswap X uses a design that they gave us credit for, which is cool. But they use an optimistic design in their theoretical white paper and for how they could do cross-chain swaps. Um, but I think we're like maybe skipping ahead. So I'll just for everybody to know what the hell I'm talking about by like an optimistic oracle. Um, Maybe we just go back there for a
Should
second,
we
and
draw it
then
out for assuming
yeah,
people?
yeah, 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 yeah,
Okay.
yeah. You got this pretty whiteboard, so let's use it.
Yes. Okay, so let's do it in terms of what, like a bridge? We'll just do the basic
Well,
bridge, or
let's go one step more general. Let's say that the concept we're trying to move towards is what we call like assert truth. So we're going to say there's a truth that we're trying to assert,
Okay.
and uh, yeah. So uh, the unit here I want there to be is like some statement that is publicly verifiable, and that is our one constraint. There is some public way, like this information isn't private; it's publicly verifiable.
Well, I mean, this
Um,
would be like the prediction market example. Like you could do like, who who is the president of the United States or something,
Yeah, and
or whether it's
as you
publicly
know,
assuming it's publicly verifiable.
exactly. There's like there is some wiggle room here, which gets into the whole more theoretical thing, but like a computation 1 + 1 = 2, easily verifiable, actually
Sure.
mathematically verifiable. Um, was this transaction mined on this blockchain? If that blockchain is doing its public blockchain thing, then yes, that's publicly verifiable. Who won a soccer game should be publicly verifiable, that
Right.
kind of thing, right? So we'll make our unit of our Oracle unit here. We'll say is this truth we're trying to assert, and the process, the optimistic process, is uh, somebody proposes a truth as true. So step one is like propose. Um,
Pose. So he's gonna place the truth. So like what do we do? Like we could do, like we'll do a soccer score. USA v Germany 2-0. It'll be some string.
yeah,
And
there's string, and let's just frame this. This string is true, right? Is what we're trying to say.
yep.
Uh, and again, yeah, that string could include like a transaction or like some whatever, but it's interpretable. Whoever wants to interpret this string, they just need this string to be proven to be true. Um,
Right.
okay, so we propose this. Timer starts. This timer is the challenge window, right? Um,
Yep.
the protocol that's going to use this system sets that challenge window. Um,
So this would be, say,
uh,
we're gonna wait for 12 hours to make sure nobody disputes it, basically.
yeah, 30 minutes, 2 hours, 12 hours. Like your challenge window can be maybe a function of the type of truth you're asserting here. Um, and then in the optimistic path, there is no dispute during the challenge window, and the challenge window passes and ends, and we have this truth is now taken as true, and you kind of settle this
Use
contract,
value.
and the yeah,
Cool. Or settle.
easy,
It's a better word.
yeah.
Yep.
We use the word settle in the contract, but yeah, fine. And yeah, so in this, the one other detail I didn't include is the proposer also posts a bond, right? There's some bond that they posted, and this is an economic incentive for them to not post bad or inaccurate truths. Um, and if you want, there's sort of an optional reward thing here too, that the kind of the person that initializes this contract could also set here as well. So and
So
at
he would
settle,
have he would send over a token to him for just putting this
sure.
in. Yeah.
And we can talk through it. It's like a lot of the time that reward isn't needed. There's sort of like an embedded incentive for people to propose things
Right.
just because they want to use the system. But if just for completeness sake, that's something we can add here. So settle in the optimistic path would also move all the funds where they need to go. So the proposer would get their bond back, and they would get the reward if there is one. Right.
Yep.
So now we talk about the disputed path. Uh, it's starts the same, and then during the challenge window, another actor called a disputer is going to come in and dispute this. To do so, they have to match the bond the proposer posted.
Okay, so she'll.
And okay, now what happens? So first thing that we do, and there's different ways you can construct this, but the kind of the design pattern we're pushing towards is that if a dispute happens, the initial assertion is forever not true. Like you can never get this market will never resolve to true. It just gets thrown away. So anyone that wanted to use this truth, they would have to repropose it a second time and go through the process again. Basically, the only way a truth is ever asserted as true is if it is undisputed during the challenge window.
Right.
And we do this for like game theoretic reasons, basically, so that we can kind of talk about how this would make it extremely costly to bribe the system. That's what we're trying to do here.
Well, and you don't have to wait for the dispute to settle, right? You would.
Correct.
It would go over to dispute land, and then somebody else could instantly propose, and now it's just 12 hours, not however long it takes the dispute to go.
Exactly.
Yep.
And so a lot of use case here in like prediction market, somebody might propose something maybe by mistake, or they proposed it too early or something like that. So it gets disputed. That result gets thrown out, but someone could immediately propose now the like right answer, and then it would go through and work out.
Right.
So that's the design pattern. So just to finish it off, right? So if it's disputed, this assertion is like thrown away. It's not going to get used by the integrating protocol. But we still need to decide who's right, the proposer or the disputer. Who gets, and what we're really deciding here is who gets the bonds. Do the bonds go to the initial proposer, or do they go to the person that disputed them? And that's where we go, dispute resolution. And specifically, dispute resolution where the outcome is who gets the bonds, who doubles their money, and who loses their money. Of course, the person that gets the bonds is the one that is right. Like, if the initial
Right.
assertion was true, the disputer will lose their money. If the initial assertion was not true, the proposer loses their money. So then how do we decide that? That's where we use the UMA like token holder commit reveal voting shelling point voting scheme, right? And UMA token holders get asked who's right. They vote in secret. They commit their votes in secret, and then they reveal in the second stage of the commit reveal process. And this process has now worked for a few years and worked pretty well. And we figure out who gets the bonds.
Cool. And then, I mean, how many disputes have you had? Do you know?
I really should always know this off the top of my head.
I don't know.
But
like, I know we have a similar system, and I know it's always
yeah,
I don't know off the top of my head either. It's just I know, like, theoretically, because this is one of those things, like, theoretically, if this works, no one will ever get disputed, right?
yes. I mean, we could talk about all the
Right.
really weird edge cases that I think we've thought through too. But if this works, no one gets disputed outside of mistakes, right? Which do happen. So we have had like on the order of, I don't know the exact number, but on the order of like 100, maybe 200, like, but 100 probably, like, disputes that some of them are really trivial. It's like literally like the proposer just made a mistake and they were just obviously wrong. And others are pretty controversial. And these are mostly related to polymarket prediction market requests. And most of the controversy generally stems from the fact that like a question was written and the world changed, and it's hard to, and like now it's kind of like it's basically like it's not completely clear what side should be right.
Yeah. No, I mean, is there a way in your system, like, because could you resolve it as nobody loses money, will you just get your money back? Is that a choice?
It depends on how you construct the contract here.
Okay.
it is definitely like, yes, that is possible. Um, I'm kind of leaning away from that pattern, but it is definitely possible that it's basically like 50-50 or indeterminate or something like that has been, you can construct a contract. So like that is a possibility.
Well, I mean, you always have the example like with price feeds, like if you're doing a price feed and let's say the price of Ethereum is $1,800. If somebody posts 17.99, is it right or wrong? Or like, and especially if like exchanges weren't in there, you know, like
Yeah.
it could be,
I mean,
like it could be disputed, it could not be disputed. Which one's right? It's really, really hard to tell. Like how do you guys
yeah.
sort of think through those pieces?
So the constructor of the contract writes a rule set that's like, here's how my assertions, my truths should be validated or determined, right? And the kicker here is kind of like, by design, there is fundamentally human oversight at the end of this process. So if you write a rule set and there is something that just was not contemplated or considered in it, you do end up getting UMA token holders to kind of decide. And our whole goal here is like, unlike Claros, which really is a decentralized court system and like is designed to have like arbitration and like kind of like almost like a truth finding mission. Um, we like don't want to do that. We want to just be like, keep stuff. Well, it's just a different system. It's like
Right,
we want the questions being asked to be deterministic. We want it to be like, okay, clearly this is right, clearly this is no. It's just there's kind of like a little bit of wiggle room. Like even stuff that is purely deterministic or should be purely deterministic isn't always clear. Like
right,
and that in those cases, um, like Nick, your example of, is the price of Ethereum 1800 or not quite 1800, right? If you think about like an exchange trying to set an option payout of an option that settles like where the strike is right at 1800 bucks,
yep,
like somebody makes that call, the exchange makes that call, and there's a rule set and there's ways that they go about trying to follow those rules. uh, I look at that as a great example for what UMA token holders should do. There's a rule set, and they're trying to follow the rules as best they can. And in a sense, it really doesn't matter if it's 1800 or 1799, like as
right.
long as you're consistent, as
Yeah,
long
well,
as
I
the
mean,
rule
like,
set is
do
consistently
you
followed.
guys, who manages the rule sets, I guess would be the question. Like if do you, because you could theoretically create a poly market pool that would just say like, is it above $1,800 with no explanation given? Does then it
Yeah,
just default to you guys get to make your own rule set?
this is kind of like um, this is where I think there's still a lot of room for experimentation. So like Polymarket has an incentive and desire to um, keep things consistent for their own users,
Right,
right? So Polymarket wants consistent, predictable results so that like people trading on the Polymarket platform don't like go on Twitter and be like, "This is crazy. I don't understand what happened here." Um, but there becomes a really interesting dynamic where some of the Polymarket power users um, actually really enjoy nitpicking rules and finding out like kind of like what they think are weird edge cases
right,
because they can maybe make a lot of money, even though I would argue that if you zoom out and you're like, well, if you end up having a market resolve to like what feels like a really weird outcome because of like a missing comma in a rule in a question or something, that's like net bad for the platform. Anyways, it becomes really interesting. And I think from Uma's perspective, we just want to follow the ethos of the integrating protocol. And there's sort of like almost like a sense of precedent that gets set with how we work with different protocols.
super cool. Yeah, no, I know for us it's for almost all oracles, this is really, really hard.
Yeah.
And then, like I think the next piece would be like, you guys have been, as you had kind of talked about with the Uniswap X example, a lot of people are moving towards optimistic designs for cross-chain pieces.
So let's talk about that.
Yeah, explain how that would work. We can walk through.
So in many ways, let's go in a like completely different direction.
Okay.
We want to build like a cross-chain bridge. And we built Across as a cross-chain bridge, really to use this UMA settlement system, or this UMA, or use UMA as its security system. So, okay, Across is a design where users submit orders for how they want to bridge things. So Nick, you want to bridge 10 ETH from Ethereum to Arbitrum, we'll say. You basically have that order. You, I'll keep it super high level, but you basically send your 10 ETH into the Across system. We then have relayers, which you could call market makers, or Uniswap X calls them fillers. They compete to fill your order on the destination chain. They fill your order with their own funds, so they send you like 9.99 ETH on Arbitrum, and then they effectively submit to the Across system a repayment instruction that says, "Hey, Across, I filled Nick on his bridge order, and I want to get paid back my 10 ETH now." And like a really interesting feature of the system is that relayer can actually ask to get paid back on any chain in our system. So they could say, I actually want to get paid back, not on Ethereum or Arbitrum, but actually on Optimism. Ignore that detail. But basically, there's like a repayment instruction that they create. And what Across does is it aggregates these repayment instructions from hundreds of bridge transactions, and theoretically could be thousands, but it aggregates them, or tens of thousands. It aggregates them over what's basically a 30-minute period. And then that batch of instructions, it creates, we call it a bundle, but basically a data structure, kind of like a Merkleized data structure that says, here are all the repayment instructions. You can see where I got them from. They're all written on chain, on Arbitrum and Optimism, on Base, on Ethereum. Here's what they all are. Here's the batch of them. I'm going to propose as a truth that these repayment instructions are correct to the optimistic oracle. There's a challenge window where anyone can say that's not correct. And after it passes the challenge window, I will then go and repay all the relayers in our system according to the repayment instructions that were just optimistically verified.
Super cool.
Did that make sense to you, Nick?
It made sense to me, but yes, I worry it may not have made sense to everyone else. I think so basically he would grab this, and then with this there would be some proof that he has sent the user 10 ETH, and then he would gather up all of his proofs and go submit them in a batch to
I would be careful with the word proof, because a lot of people now think of proof as like a ZK proof or something like that.
Sure.
Here, there is simply data, like
A signed
publicly
message.
verifiable data. Yeah, there's publicly verifiable data that this action happened in this case.
So transaction
this repayment happened.
Something.
Yeah, exactly. So, we're able to take all of this data, which if we were to, so this goes back to a really interesting kind of system efficiency. If we were to validate each bridge transaction independently, we would be sending messages, like a lot of messages back and forth that we would need to validate as true. And those messages, we could use the optimistic oracle or use other types of messaging systems, but it's actually expensive. And there's, in my opinion, quite a bit of security risk in terms of passing all that stuff back and forth. So instead, we are just taking this data, these transaction hashes, which anyone can verify, and we're putting them together into one thing it's a batching, off-chain aggregation of this information, which makes things way, way cheaper for us to validate all these messages. Like we kind of do this one big computation, but the cost of that computation is the same as doing like a small, like an individual message passing. And it means that we're able to kind of amortize the cost of this verification over hundreds of transactions, which makes it really cheap.
So is that the reason you find people use you, because you're cheaper, or is it just you have liquidity or something like that?
It's cost. Like this is actually, yeah, it's cost. I think it's cost and speed. So there, and this is specific to this type of design, but because we have this relayer that's filling users with their own funds, the actual bridge speed is very fast. Like that relayer fills a user quickly, and that relayer can choose to take, this is like very technical to bridging, right? But the relayer can choose to take some finality risk where they could actually fill the user before the origin chain has full finality. And they can do that if they are willing to take that risk, if they feel like it's worth it. Whereas if you have a protocol that's, say, using other people's money, you can't really take finality risk with other people's money. It's like would break
Right.
everything. So that's a kind of cool feature. And then because from just a gas perspective, because the deposit and fill transactions, they're actually really lightweight. They're basically like ERC20 transfers. The actual gas we're using to do a bridge is very low. And then we secure the whole thing with this aggregated off-chain message. So we kind of just do a pure like gas cost analysis. This bridge just costs less gas,
Right.
makes things cheaper.
Yeah. And sorry.
No, I was just gonna say, like, I don't want to, like, we're talking about Oracle stuff here, so we don't need to go too deep into that.
This is
But
no, this is Oracle stuff nowadays. This is I mean,
um,
can I ask how, we had I had on the show actually like 6 months ago or 4 months ago, the Connext guys. How is this different
yep.
than Connext?
So in many ways, Connects and we're very friendly with them and think highly of them too. Connex's system also has evolved. Like their V1 is very different from their V2, and their V2 is more like this. But what is different is the way we batch aggregate all of our messages. Like
Okay.
Connext is not doing that. It's more like they're messaging on a per bridge basis. And there's reasons for that too, which is fine. There's still optimistic components where they're like, say, only sending messages in the case of a dispute, that kind of thing. But we're doing this batch messaging. And the other core difference here is Across does have a liquidity pool that is like it's you can almost think of it as like a single asset cross chain liquidity pool, which does not need to be big. It's kind of like providing working capital for the system, and it actually allows us to save on gas costs because rather than like individually escrowing each user's bridge transaction before we repay the relayer, um, we aggregate them into this pool.
So like when he
And for
deposits this 10 ETH, it'll just go into a giant pool.
no, the only thing I'll push on is not giant. It's actually purposefully like other protocols want to have like huge LP pools or they need them to
Oh,
have
right.
good pricing. We actually don't. The LP pool here can be quite small. But rather than like think it almost from like a gas cost perspective, if I were to individually escrow each user's deposit, there is more overhead because like then I need to store it individually and then I need to repay it. I need to pay a gas cost to move it out of there individually. Whereas if those deposits were to go into a pool, I can batch repay people without with much less overhead.
Okay.
It's
No.
super technical, Nick, and like I've only realized like been staring at this recently because the bridge space is really competitive. Um, uh, these are some design decisions that I don't think we fully realized at the time the implications. But I'm pretty happy we made them because it does just like save us on gas costs.
Yeah, no, for sure. I guess we can kind of rant on bridge questions for a minute. You know, like I think the one place that the space is moving, you know, if you had optimistic designs, everyone sort of seems to be on the bandwagon that the eventual end game is zero knowledge proofs for it also. You know, you would have light client here, zero knowledge proof, or just a light client bridge to pass over the proof, and then this wouldn't be needed, right? You know, like do you also see that as like an end game, or do you see it more as like, yes, but we're 20 years away from this or something like that?
Um, my views on this have changed. I did see it as an end game.
Ooh, good one. Let's hear it.
Yeah, well, I did. It's like, wait, if I can prove deterministically with math, like that seems better than having this like challenge window kind of concept here.
Yep.
Um, and turns out I actually don't think it is better because those proofs are relatively costly. Like even if they're fast to, uh, even if they're fast and even if they're relatively cheap to prove, there's still a cost. Whereas this type of optimistic system, there is like literally zero cost. We're just saying this is true and off chain. All your computation is done off chain. And in this particular example, if you think about, I've now got like 10,000 bridge transactions going between, let's say it's 20 chains or whatever. Um, if, and that happened in a 30-minute period, I would have to efficiently aggregate on each chain the messages between each origin and destination chain, create a proof for each of those routes, um, then relay that proof and run it on the destination chain. And you've got like a kind of exponentially complex problem there. Doable. It's totally doable. Like, but there's a cost to that. Like I've got to generate those proofs. Maybe that's off chain. Maybe that goes to zero. But then I have to like run the proof on chain. That will never go to zero. That'll always have a cost. And how will that compare to batching this and like waiting half an hour? I'm not sure that it's going to be better, right?
Right. Well, I mean, would you say then that you might have optimistic systems that fall back to zero knowledge proof systems?
I think what you might do is like in the dispute resolution stuff on the UMA side, they're on like the right side of your board
Yep.
here. Like rather than ask UMA token holders, was this bundle properly created or not? You use a ZK proof to prove that it was
Right.
correctly or incorrectly created. That makes sense to me. But yeah, I still think there's a lot of use case for optimistically asserting things and not even bothering with the proof generation, instead waiting some period of time. So
Nice.
yeah.
Yeah, well, I think
And
that
like
was like, what was it, Nomad's design, which was like optimistic and then fall back to a zero knowledge thing. Or
they never implemented the zero, they hadn't
yeah,
gotten that far. There's like I think that
rip.
was yeah. But like I think that kind of stuff is pretty interesting
Okay.
generally. Um, yeah, and that seems promising. And like you could argue then, okay, well, like what's the value of like the UMA voting system? It's like, sure. I just also think the UMA voting system here works pretty well. It's worked in production for a long time. And for anything that is not deterministic, like prediction markets or price data, you can't create a zero knowledge proof of like who won the soccer game. Doesn't really work that way. So
Yet.
yet we'll see.
Right.
We'll see.
Um, cool. And then I would say on the bridge, my other smart sounding question I'll say is like, do you run the risk? Like, I know you were saying like people are playing with finality risks, right? Like, do you see that happening a lot? Like would love, like
Yeah.
are people doing it very, very instantly? And
Well, but in a very, I think, a very intelligent way. So it's um, uh, like mainnet Ethereum, it's 12 minutes to full finality right now, I guess. And your risk of there being a reorg that happens within 2 blocks is pretty low. But then like what's the risk that there's a reorg that actually affects you and your transaction where like you don't get paid back? I don't even know how to look at that, but it's pretty damn low. So what we really have are relayers for relatively small transactions. So not like
okay.
no one's really doing this for like, $5 million type transactions. But if you're doing a $2,000 transaction and there's like a risk that they think is 0.0000001% chance of a reorg, you're just kind of like, okay, cool. I don't care. I'm just going to send the funds. And worst case, I lose $2,000, but the probability of that is tiny. Um, Upside is that I get the fees associated with this bridge transaction. And so
Yep.
it's just market forces pricing that finality risk. And I'm pretty sure you're aligned with me on this one. I love it when there's a competitive market pricing risks like that. It's pretty cool.
Yeah, no, I mean, I would just wonder, like, is it like a race to the bottom in some ways? Like, basically,
That's what
like,
we want. We
well, no,
want to
but I
race
mean,
to the
like,
bottom.
in terms of like, if you're willing to take all the finality risk out there, then like you would eat up every fee, and nobody else would be able to compete with you, right? Because you would, so it would like slowly drive down to like you're doing it intra block, like you don't care at all, and that would push everybody else out. At which point, now all of a sudden your system's really risky if somebody catches on, right? Or like
Well, what's the risk? The risk is that the relayer like loses a bunch of money.
right,
And so we don't care about that. You chose to take stupid risk and you lost a bunch of money. What we would care about, or what I would care about, is that if like there's kind of one monopolist, if it ends up being like one dominant relayer and then he goes bust, like is there anybody to take his place, right?
right.
So there's sort of like relayer diversity matters. Um, but like say there were 3 guys that were all doing this, and then one of them gets unlucky and goes bust. The other 2 are like, oh shit, we don't want to be that guy. We'll dial back our fill times. That'd be great. Good outcome, I think.
Nice.
Or great, be fine outcome. Yeah.
Be a fine outcome. Okay, no, that's super cool. And then I mean, for these guys, like my other question would be like, what sort of bond do they have to put up to assert these things? And does it have anything to do with the amount that they're bridging?
So bonds are again a parameter of the integrating protocol. So whoever wants to use the optimistic oracle sets the challenge window and sets the bond
I mean,
size.
this is for a
Um,
cross using
for
it.
a cross, yeah. So for a cross, well, I'll answer your question generally. So in the general case, the bond sizes, I think it makes sense to set them kind of corresponding to the value of the question being asked, right? Um, but it's context specific. Like it's because a dispute just throws out this assertion. You can actually say, well, wait, it doesn't really matter how valuable the data is. We just need the bond to be big enough to incentivize disputers to check things too. It's doesn't really matter. And uh we've seen, I don't think we've I don't think there's any like science yet um of exactly how we should set these things or think about it. We're still kind of experimenting. Um,
Okay.
I'm actually blanking on the bond that across sets right now. Um, yeah, I'm blanking on how we size it. It's big enough that like it hurts to make a bad proposal, and and also disputers are pretty happy to say this isn't right. Uh, uh, but it's like not so big that like you also don't want it too big that a disputer would be like, well, shit, like what if I happen to be wrong in my dispute and I just lost, 50 grand or something? That would suck.
Yeah. I mean, do you guys see self disputes in your system?
Yes. I mean, so one of the things that happens in a cross right now is uh like sometimes the data, like the RPC data coming from a new chain, um, might not be perfectly robust. So like,
Really?
uh, it's never, no one, like, it's not making data up, right? But it might be missing some data where like it kind of goes down for a second. And so that can cause issues where like a proposal is
Wow.
made and then later on we get more data that's like, wait, actually that proposal is missing some data type thing. You know?
And then
Um,
you'll see the guy dispute himself or something.
yeah. And like in our system, there is a cost. So I glossed over this, but when a dispute happens, a portion of those bonds gets paid to like UMA token holders. This is like an
Yep.
anti-spam thing too,
Well,
just so
exactly.
that
Yeah.
yeah, yeah. I think you guys probably have something similar, but
Yeah, because well, I mean, you see it like if you submit a bad price, or a bad report here, and you're like, oh shit, like you're very incentivized just to take it off yourself, and we see a lot of those.
yep,
So,
which is good. Like we
yep.
actually, if it's bad, but we don't want there to be just DOSed bad proposals and self disputes, right?
Yes.
So
You don't want to have to
we
vote on
call
these things.
exactly, and or it could make our system kind of unusable. So we have what's called like a final fee that goes to the token holders, and it's sized like at a couple $100 type thing to just make it make it not be DOSable.
Right. Cool. Well, yeah, this was a great overview. I know we're like kind of wrapping up on an hour here. Like what would you say, like oracles moving forward? I know you're a big fan of the optimistic piece. Like what do you think they're going to be used for? What's going to be like the big use case over in the next bull cycle for the next 2 to 3 years? You think we're still going to be doing price feeds and bridging stuff, or will it be something different?
Um, so I think there's a few angles to this. Um, I think optimistic systems and optimistic design makes a lot of sense in a cross-chain world. Um, and even just, yeah, like, and the reason here intuitively is in a single chain world, you want to do everything like synchronously, like you want to do everything atomically. And so their optimistic systems don't work because like you have this challenge window, and if you're trying to do things atomically, it doesn't make sense. But as soon as you go cross chain, you've already created some asynchronicity because these systems are operating independently. And so an optimistic design in a multi-chain world like makes a ton of sense because I already have to like I've just gotta I can't do things atomically anymore. Um, so I think there's like a lot of use cases around fulfilling intents, like was an intent fulfilled in a cross-chain world, I think makes sense from like optimistic order stuff. And so I think that's interesting. Does that look like an oracle becomes an interesting question now, where like you just discussed, so maybe we do the optimistic challenge stuff, and in the disputed case, what do we do? Maybe we do a ZK proof or whatever. Um, I think like this UMA dispute resolution system actually works pretty well, and might compete or at least hold its own with ZK proofs for some time. And that's where my views on this have kind of changed. So I think, okay, that's all like the cross-chain, multi-chain intent world. All the price feed stuff, we're not focused on price feeds right now because, well, the optimistic system is too slow for price feeds. I'm curious where that all goes, and I think there's still room for lots of innovation there. And you said one other thing, so kind of like cross-chain stuff, price feed stuff. One other out there idea might be, do we use things like the optimistic oracle to prove or validate statements that AIs are making? And so if you think you have a lot of statements being made by systems that are kind of a black box, there is like a kind of cool or fun idea. Like, could we use an economic game to actually have those like LLMs put money behind their statements or prove that their statements were actually accurate? It's kind of a fun idea to play with.
Well, are they deterministic though? That would be, I feel like that would be the hard place. Like because I think if you ask ChatGPT a question, for instance, and if I ask the same question, I believe you get two different responses. So
this is where this would be like open research problem.
yeah.
Can you ask ChatGPT to make an assertion of a publicly verifiable truth, right? And then, like, let's just say we're picking on ChatGPT. We ask GPT-4 to do this, and we then use like this truth assertion pattern, and the disputers here are other LLM models or whatever, right? And so the other LLM models are trying to make money by proving ChatGPT wrong, but also they'll lose money if they say the statement is wrong when it was actually correct. And we basically have an economic game with like a crypto kind of infrastructure underneath it. But we have an economic game with this crypto infrastructure that allows these entities to battle it out to see whether things are actually right or not. It's an out there idea, but could be quite fun.
Yeah. No, it could be cool. This is, yeah, the first step to giving AIs money, right? No, this was super fun. Kind of yeah, I think that was great. Where can people find out more, and what should we be watching out for over the next few months?
So our website's uma.xyz, uma.xyz. Links, of course, to like our Twitter and our Discord and all that kind of stuff. The bridge we have, which we do run as like a separate project, but affiliated, is across. So the domain is across.to, across.to. And it really is like the cheapest, fastest bridge, which is kind of cool. So yeah, and like Twitter links are good and lots of information there. I think, yeah, Nick, I think there is going to be a round 3 session for us to have, because we are working on some new ideas on the UMA side of things around Oracle aggregation stuff that I think is going to be fun, but we're not quite ready yet.
Are you doing price feeds? Is this UMA jumping back in the game?
We don't have a better design for price feeds yet.
Okay.
I don't think so. We are not doing price feeds, but I'll peek at it as being infrastructure that's related to price feeds. But
Okay.
like I very openly think that like the optimistic Oracle design, I think, can give you very sharp prices and accurate prices, but the challenge window of the delays is too long for most DeFi use cases, practically all of them right now. So that's not a game we play in.
All right. No, I'm always just wondering, like with aggregators, I know we had like the bridge aggregation, we had Hashi from Gnosis, that project on. It was interesting. So
oh, they can't. I gotta watch that. I'd be curious to watch that.
Yeah, but it's kind of exactly how it sounds. It's a bridge aggregator, and so but it seems like everyone's sort of moving in these same directions for how to secure things. It's just aggregate, throw in
Yeah.
optimistic pieces, you know, like anytime it sounds things move too fast or people think they can do something else, it's always too good to be true almost. So
Yep. But incrementalism, little nuggets come out along the way.
yeah.
So, yeah.
No, but thank you so much for coming on.
Thanks, Nick. Appreciate it.